Hello students, today I am sharing information related to dielectric properties of material. As you know, dielectrics are basically insulating materials. So we define dielectric materials as the insulating materials which undergo polarization on application of electric field. To quote few examples, air, paper, hydrogen, diamond, benzene. Even distilled water can also be treated as dielectric material. There are two types of dielectric material, non-polar dielectrics and polar dielectrics. Non-polar dielectrics are the one in which effective center of positive charge coincides with effective center of negative charge, that is in absence of electric field, as you can observe in the figure. On the other hand, polar dielectrics are the one in which effective center of positive charge does not coincide with effective center of negative charge. That is even in absence of electric field. And this is the only one type of dielectric material in which permanent dipole exists. Now moving to different polarization mechanisms, it is observed that a dielectric material can undergo four different polarization mechanisms, out of which the first is electronic polarization, and this polarization occurs due to the displacement of electrons. So in order to understand that polarization mechanism, consider one such dielectric material. In absence of electric field, the arrangement of charges in a dielectric is as shown in figure 3a. Whenever electric field is applied to such dielectric, only electrons of the material will undergo displacement, and hence the name electronic polarization. And whenever electrons of the atom undergo displacement, there will be creation of dipole moment, which will be given by mu times alpha E, mu equal to alpha E times the applied electric field, where alpha E is called as electronic polarizability, and for monoatomic gas molecule it is given by epsilon naught into epsilon r minus 1 by n. And this is the only one polarization mechanism which occurs in all the dielectrics. And the second polarization mechanism is termed as ionic polarization. And here you need to remember that there is a restriction for this mechanism, that it occurs only in those dielectrics where ionic bonds are there. So consider one such dielectric material having ions. So in absence of electric field, the arrangement of ions is as shown in figure 4a. When electric field is applied to that, ions undergo displacement, and hence there will be polarization and it will be ionic. And whenever ions undergo displacement, there will be increase or decrease in the bond length between the ions, due to which there will be creation of dipole moment, which will be given by mu equal to alpha I times applied electric field. And the third polarization mechanism in dielectrics is the orientation polarization. Even orientation has a restriction that it occurs only in polar type of dielectric material. So consider one such polar dielectric material. In absence of electric field, the arrangement of permanent dipoles will be random as shown in figure 5a. On application of electric field, those permanent dipoles will orient along the electric field, and hence the name orientational polarization. And the amount of dipole moment that has created due to the orientations of dipole will be given by alpha O times the applied electric field. In turn, that orientation polarizability is given by mu square by 3 kt. And the important thing one has to remember is only this is the polarization mechanism which depends on temperature. And the last and final polarization mechanism termed as space charge polarization. and it occurs only in multi-phase dielectrics. So consider one such multi-phase dielectric. The arrangement of charges in absence of electric field is as shown in figure 6a. As and when electric field is applied to such multi-phase dielectric, the charges near to the interface, that is between the applied electric field metallic plate and the dielectric, only the charges will undergo displacement, and thus the name space charge polarization. And the amount of dipole moment that has created due to the displacement of charges at the interface is given by mu equal to alpha s times the applied electric field. Now, the total polarizability of any dielectric can be written as sum of electronic, ionic and orientation. Usually, the space charge polarizability will be neglected because as it occurs only at the interface.